Hey guys, so recently quite a few of you have requested an episode about why leaves change colors in the fall. And we have really good news for you.
We've actually done that episode already.
Yep.
But we love fall candles. We love the fall season. And we love y'all. So
Yep.
we decided to give you a little fall into the holidays gift of learning about why the trees are changing around you from past Melissa and Jam.
So enjoy learning this cool thing that we already taught you guys. It's a cool one. I like this one a lot.
This is one of my favorite ones.
Yes, it's really cool. And we'll be back with a new chemistry episode next week.
And now on to the show. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of everyday life.
Jam, I don't have to ask how you're doing today because I saw you in person.
When?
This morning.
Oh, it's weird. You saw me. I didn't see you.
Yes, you did. Don't make our listeners think I'm a crazy, creepy person.
Like, I was right behind the car, hiding behind that tree.
We went for an outdoor social distance walk with a little bit of coffee this morning. And it feels so nice when we get to see each other in person and then record, almost as if it's old times.
Yeah, seriously. Seriously. I'm like ready for it to not be old times, but to be current times again at some point.
Current times, yeah. Somebody said, I think it was my roommate, said, remember when times were precedented?
I like
good.
that. That's good.
I missed that.
Yeah.
Okay, so I teased this a little bit last week. This week we are talking about why leaves change color in the fall.
Awesome.
I have had this episode planned for honestly and truly 1 year. I thought of it after we had recorded all of our fall episodes last year.
Oh, yeah. I remember that.
So I've just been waiting for the prime opportunity. Plastics, slid in there and took the first fall spot. But now that the plastic series is over, we're going fall, baby.
And in Texas, at least, it's a little delayed. The fall stuff doesn't really happen, right at the beginning of the technical first day of fall. So, but I'm excited about this. We got to see a little bit of what fall is like on schedule in Indiana. And it's always,
yes. And
yeah.
Your wife sent me some beautiful pictures because she and I both love fall leaves together. We went to Washington together a few years ago in the fall, and it was gorgeous. So,
dude, yeah, it's very, very cool to get to see it be like really, really fall. And we do get that here in Texas. It just takes a little bit longer for sure.
Right. And it's short-lived.
Yep. It's like you get like a week of that fall look that you hope for. And then the next week, all the leaves are on the ground and you're raking them for hours and hours and hours.
That's only if you're a homeowner.
Yeah. Yep.
I don't have to rake any leaves.
Yeah. Well, I've got plenty actually. If you want to get a little bit a taste of what's like to own a home, you could come rake some leaves.
That's okay. I think I'm good.
Are you sure?
I'm sure.
Okay, invite's open.
I've also, in those cartoons where people run and jump in piles of leaves, all I can think about is if that leaf pile has been sitting there for a while, there is very likely some kind of animal in it. Or a squirrel, some snake, some bugs.
Yeah,
who knows?
They're just also dirty. I mean, you wouldn't like really want to jump in a pile of dirt, but dead leaves are not that different. And if it's rained at all and they're wet under there, it gets gross. I mean, I'm messing with them and I'm not even trying to like play in them, and I get very dirty just handling lots of leaves. So whatever, man. People do your thing, jump in the leaves you want to, but I'm going to pass.
Well, here's the answer for why leaves change colors.
Okay.
And it's really the answer for why they're green in the first place, and then also why they're red, orange, and yellow.
Okay.
And the answer is organic chemistry.
Oh, it's so simple. What an easy answer.
My favorite My favorite topic and my favorite answer. And that's it. That's the end of this episode.
Nice. All right.
Just kidding. So what happens is in leaves, there are highly colored organic compounds that hang out in leaves and they make them pretty. And we're going to talk about why they're hanging out in leaves and what they're doing and why in the fall the colors of the leaves change.
Okay.
But it is all, everything that you see, all the colors in the leaves are all due to organic compounds.
Dang. Okay. I feel like I've learned about just the green color in plants before in like biology and stuff. And I cannot, it's like my brain wants to know the word really badly and would think it knows it, but I can't muster what that word is.
Well, hold on to it and maybe it'll come to you. Okay. I'm sure you do know it. And I'm sure people at home are thinking, I know it. But we're going to just wait for just a second. Okay. So remember when we talked about light and colors on the bleach episode? It was long ago enough that I wanted to review it.
Okay.
So we talked about how highly colored compounds usually absorb light in the visible region. And whatever they don't absorb, they reflect back to us. And that's what we see as color.
Right.
And these highly colored organic compounds are usually called pigments or dyes. And they have a lot of alternating double bonds in a long carbon chain. And that's called conjugation. And if you have a certain amount of conjugation, that is what allows these compounds to absorb light in the visible region and reflect light back to us. Sometimes if you're too highly conjugated, it'll go in out of the visible region. It just depends basically on the amount of energy that compound's amount of electrons can absorb.
Okay.
Is the best way I can put it. They absorb light in specific energy packets, and that really determines the colors that we see. This is a simplified, boiled down version. If you want more on it, go back to that bleach episode. So all the colors of the leaves that we see in trees, they're absorbing light in the visible region and reflecting back.
Okay, right.
And the one that you probably know best that's responsible for green that your tongue can't quite remember is chlorophyll.
Yes. Yep. Dang it.
Yes, that's it. So chlorophyll absorbs the sun's light in all the regions except around the green region. And it uses all that light energy that it has absorbed to feed the plant through photosynthesis. That's pretty common knowledge. But the reason we see it as green is because the green light is reflecting back to us.
Right.
All the other visible light it absorbs and uses carbon dioxide and water to turn into food for the plant.
Got it. Okay. So for some reason, of all the colors or all the ranges of energy, it just doesn't absorb green on that scale.
Right.
Huh.
It just absorbs energy in the specific wavelengths in more the red and the blue region, but not the green region.
It's weird because it's right in the middle too, like Roy G. Biv or whatever. It's like, his middle name. Roy's middle name.
It is right in the middle. And we, organic chemistry, so in my lab, if you go all the way back to how do we turn sunlight into energy, in my master's degree research, we looked into how to imitate photosynthesis. And you can really put sort of antennas on molecular structures to fine tune where they absorb light. So it does kind of just depend on the molecule you have in the different structures. I have some suspicions as to why it absorbs in the red and blue region, but it doesn't really matter.
Yeah.
So that's why we see plants as green, is the chlorophyll absorbs the light in the reds and blues, and they reflect back the green to us. But then in the fall, chlorophyll production slows down because plants don't have all the warm temperature and the sunlight they need to produce chlorophyll. So while that happens, the chlorophyll starts to break down and the green of the leaves starts to fade away, and two things happen. One, we can see the colors of other pigments that have been in the leaves all along.
Okay.
Oh, so in the same area of the leaves where the chlorophyll lives, there also live other pigments, and these are primarily known as flavonoids and carotenoids.
Flavonoids, that's a familiar word, I think.
I think that they're common in foods, they're common in plants, and they seem to be a jack of all trades. They do a ton of things, and it was hard for me to narrow down what they did.
Mm-hmm.
But the carotenoids have a very interesting function. They live in the same part of the cell the chlorophyll does.
Mm-hmm.
They're much slower to break down. So after the chlorophyll starts to break down, you can still see the color of the carotenoids, the oranges and the yellows.
Oh, gotcha.
And they're different color, which means they absorb in a different region of light.
Mm-hmm.
And so the carotenoids are handy because they can absorb in the region of light that the chlorophyll doesn't.
Mm-hmm.
So they can use sunlight more efficiently in conjunction with the chlorophyll. So the chlorophyll is missing out on that whole chunk of light in the middle of the visible region.
Mm-hmm.
Carotenoids come in and act as a helper and can absorb the rest of that light in case the plant isn't getting enough. It can utilize the sunlight that's hitting the leaf more efficiently.
It's doing that all the time, even when we can't see that color, right?
Yes.
Got it. Okay. It's there. We don't see it, but we know, because when we do see it, we know that it's absorbing different ranges of energy of light than the chlorophyll.
Yes, and there was a beautiful graph from one of our references, and if I can remember, I will probably screenshot it and post it on our social medias.
Uh-huh.
And he shows on the graph it's called the absorption spectrum, so that demonstrates where light is absorbed.
Mm-hmm.
And he shows it for chlorophyll and how it kind of misses this one region, and then for the carotenoids and how it comes in and covers that one region.
Oh, interesting.
It's pretty beautiful. It's pretty satisfying.
Yeah. I think that's cool.
Well, here's what's cooler. They do something else too. So if there's not enough sunlight, they can help the plant use the sunlight that's hitting it more efficiently. But also, if there's too much sunlight, they almost act as a blocker where they can absorb the light and deflect it away from the chlorophyll so the tree is not getting too much sun.
Huh. Wow. The opposite problem.
So they're almost like a bodyguard where they give a helping hand or they protect when necessary. They do two almost exactly opposite functions at the same time.
So the carotenoids do that, and the flavonoids do something else.
The flavonoids might also do that. From the papers I could find, they seem to play a variety of roles in all kinds of plants, and they definitely have the same yellow and oranges as some of the carotenoids do.
Got it.
I found a very in-depth article written by someone at Appalachian State University, and we'll link to it. And he went in depth into the role of carotenoids, but I couldn't find a similar article on flavonoids. It was hard to find. So they might serve a similar function. It's just hard to tell.
Got it.
It was hard for me to find information. So if there's a biologist out there that knows the specifics on that kind of pigment, the flavonoids versus the carotenoids, and if it does the same thing or different things, let me know. But they're in a lot of stuff.
Yeah. Interesting.
And two familiar kinds of pigments that are responsible for these colors. One is beta carotene.
Oh, that's familiar.
That gives carrots its orange color. It can also be yellow if it's a little diluted, so it can do both.
Uh-huh.
And lutein, I'm not sure how to pronounce it, which gives egg yolks their yellow color.
Oh. Huh.
So that's where the oranges and yellows come from, mainly from carotenoids and flavonoids. So that's the first thing that happens when the production starts to get reduced and the chlorophyll breaks down. The other thing that happens is that new pigments are generated. And this is kind of bizarre because this tree is starting to break down and conserve energy. So why would it waste energy producing new pigments right when things are getting colder and they're going to have less energy? It's kind of weird.
Yeah.
This is a little bit of mystery, which I love.
Yeah.
But I dug into it a little, and it seems that this class of compounds, they're known as anthocyanins. They're the bright red, beautiful color. So you see the bright red, stark red leaves that are clearly red. that class of compound seems to be generated as a sunscreen for the plant. Because if you didn't have that, which one scientist made mutant trees that didn't have the ability to produce anthocyanins, the leaves fell off while they were still green and they were still able to get energy if they were exposed to bright light and cold weather. So by having anthocyanins, the trees can basically hold on to their leaves longer because they have this pigment that sort of protects them from the sun. And so it exists as a defense mechanism where the leaves won't fall off as fast if it's cold and bright weather.
Oh, interesting. Okay.
So if it's a colder, brighter fall, you're going to have more of those beautiful red leaves. And if it's a cloudier fall, the tree won't have to produce as much of that to protect itself. So you'll have less of those crazy bright red leaves.
So it's kind of responding to conditions, not just trying to predict conditions, right? So it's not like,
yes,
let's be red just in case. It's more like, okay, it's really bright, even though it's getting cooler. Let's do some red.
Yes.
Okay.
And there was one, they're doing more studies on this. They haven't confirmed it, but one scientist theorized that there seemed to be more of those red leaves produced, the anthocyanins, produced in nutrient poor soil. So if it's going to be harder for the plant to get nutrients once winter hits, it'll make more of those anthocyanins. But if it's very nutrient rich, it maybe doesn't need to protect its leaves as much and it makes less of them.
Interesting. So it's a little bit of a sign of like, okay, the soil, like there's all these beautiful red trees over there, but that might also mean that the soil that it's in is not like the best for it. Something.
Yeah, maybe it's lacking some nitrogen or it's just not as nutrient rich. So the tree needs to hold on to its leaves longer to stock up energy for the long, cold winter.
Yeah, dude, that is crazy. Gosh.
I know.
I guess I just didn't really think about how much they're responding to like current situations and they're playing it as it goes. That just doesn't.
It really is alive. You just kind of sometimes forget.
Yeah. I really think of it more like it just happens to it. You know what I mean? That just is kind of how I've gone through life thinking about plants a lot of times, with some few exceptions where you think, oh, wow, that plant is like, you hear about something cool or you see a plant like leaning toward the light and you're like, oh, it's responding to stuff. Right. But most of the time I just think of them as just the time of year comes and all its leaves fall off. You know, it just doesn't seem like it's alive.
Well, and that sort of is what happens when the chlorophyll fades out and you can just see the yellow colors that were already there. But the production of the new anthocyanins is pretty amazing to me.
Does it ramp down the production of the chlorophyll on purpose?
I think it just isn't able to produce as much. Okay. There's not enough sunlight or something. I don't know the in-depth details about the plant's decision to produce less chlorophyll. It might not have the resources, or it might be that I think I read that the leaves drop because once it hits winter, too much water can evaporate from leaves, so it basically becomes inefficient for the plant to still have the leaves on there. So I suspect it could have something to do with that. It's basically stocking up and preparing all of its energy, and once it hits that point, then the leaves are free to go, maybe.
Oh, wow.
Hard for me to know for sure because I'm not a biologist. That was a lot of speculation.
Yeah.
If we have biologists who listen who know more about trees, please lay it on us.
Yeah. Dang. This is crazy, dude.
So that's it. That's the story of why leaves turn color in the fall. The short answer is all organic pigments. So if you want to wow someone and not give them all that, you can just say organic pigments. But for you, Jam, you've got to give me more than just the short answer.
Okay. Yep. Man, this is a hard thing to think of an analogy for. You know what I mean? It's like, I think the one thing that comes to mind, it's not a perfect analogy, it's just what we as humans do. The seasons start changing and we start making conscious decisions about what we're going to do. It's not like the first day of fall, the first day of winter, and we immediately bundle all the way up, especially not here in Texas.
Right.
We don't go,
definitely not.
We don't go fall all at once, and that would be dumb. Yeah, at the same time, even so, we also look at the weather every day and look at what decision we should make about what we wear that day. And
right.
one of the reasons we do that is comfort, but really more importantly behind all of that is survival. We make a decision about what to wear to stay warm or to stay cool because we want to survive and conserve energy. If we're sweating like a pig, we're wasting energy and we're uncomfortable. If we're really cold, then we are also, wasting energy and uncomfortable and also might not survive if you're out in like sub-zero temperatures or something with no clothes on. So don't do that.
Definitely don't do that.
So it seems like the trees are kind of doing the same thing. There's a change happening in their environment, and maybe it's that some of this stuff happens to it, maybe not, but there's certainly some on-purpose decisions that plants are making, changes plants are making really because they're trying to survive, just like everything else. So whether it's like the first thing just being that there's going to be less sunlight and cooler temperatures, and so it starts to make changes to stay alive and keep trying to get energy while it still can. So,
or
one of the things being that it creates those new pigments to still be able to take advantage of the sunlight during this weird transitionary time. But also, one of the things we're seeing too is just the fact that because the chlorophyll production is going down, we see these pigments that were already there because chlorophyll specifically absorbs light in the regions that are not green or reflects back. So chlorophyll is gone. And then we're seeing the other things, the other pigments that were already there, the flavonoids and the
It's kind of like carrot.
Wait, what is it?
It's carotenoids.
Carotenoids.
It's like carrot.
When you said carrot, I thought beta carotene, and I was like, "What's the other one then?" Carotenoids. Man, there's a lot of carrot-related stuff going on.
I think, although I don't know that is on purpose, carotenoids hold classes of compounds like beta carotenes. But I tried to get some clarification on where the line was drawn between flavonoids and carotenoids, and I couldn't really, and it didn't seem relevant to dig in for this episode, but there are similar classes of compounds in my mind. They're highly colored and they're found in plants.
Yeah, got it. And it's just crazy how much of this is really just boiled down to what regions of visible light energy does this thing absorb, and then what it does not absorb is what it reflects. And so we could dig way more. I'm sure a biologist could tell us way more about what the plant is doing on purpose and what is not on purpose or whatever. But just at the very, very basic chemical level, it's that we're seeing literally different substances that absorb and reflect different regions of light. And from the chemistry point of view, that's pretty simple. We see it everywhere. And for some reason,
definitely
on this large scale, we see it happening in the world around us on these trees. It seems so much crazier. And I almost always thought of it as just like the leaves were dying or something. And for some reason
that is sort of part of it.
Right. And I thought for some reason when it's dying that it was just like, oh yeah, the colors change when it dies. I guess never really thought that much more about it.
Well, it is easy to do that with a lot of the things around us. It's always like that. So that's just what happens and we don't question it. Sort of like the time we talked about fire and then said, wait, what is fire? You know?
Yeah.
You just think, I know what that is.
Yeah.
I know what leaves changing in the fall are, but you've never really thought about why that happens. And it really is just that we're either seeing those pigments that are already there or new pigments are being generated to maybe help protect the plant in certain conditions.
I was thinking those new pigments are kind of like how wardrobe-wise we have, especially in Texas, a kind of short window of fall-related wardrobe stuff. You have a light jacket. You might throw on a hat if it's a little bit cool, or just a scarf for a little bit. But you kind of have this medium region where we're just like getting by for a little bit before we actually have to go full winter mode.
Yeah, that's a great way to think of it. They basically kind of come out and protect the plant to help it keep its leaves on for a little bit longer. Yeah. I was really amazed. I think I forgot to say, but his name, the scientist who made the mutant trees that couldn't make anthocyanins, was William Hawk. And he was the one that observed them dropping their leaves while they were still green if it was exposed to cold, bright light.
Dude, interesting. Gosh. We had a tree that I'm guessing this is probably something to do with either it's on purpose or something's wrong with the tree. But at our old house, we had a tree that leaves would go through the colors and turn brown and then never fall off.
Actually, they talked about that happening too, is that some trees wouldn't drop their leaves until the new leaves came on the next year. Mm-hmm. But I don't know why.
Yeah.
I can't remember.
It was very strange. I always felt like a little worried about that tree. And when the spring came, there would still be all these brown leaves on there. So I'd help the tree get them off, and then it would help it actually sprout new leaves. Very weird.
Well, I think that is normal for some trees. Okay. I did read that briefly. I mean, I don't know, but I read briefly that some trees will hold on to its dead leaves until the new ones come. I don't know why.
Maybe I shouldn't have been messing with that tree. Should have let it be.
Maybe it was just, it knew what it was good for itself.
Yeah. Yeah.
But I didn't pay close attention to that. But I do remember reading something like that in all my sources. What happens when I write an episode is I find as many reputable sources as I can. And I try to find multiple different reputable sources stating the same thing. So I end up reading a lot of stuff. So somewhere in one of these references, it did talk about that, but it's going to be hard for me to find that again.
So let me try to wrap my sort of response explanation up in a bow. So we've got chlorophyll production goes down, and we see green because it absorbs light in the other regions except for green and reflects green. Goes down, we start seeing the carotenoids and flavonoids. They are already there, and they absorb light in a different region and reflect different colors. So we start seeing those. And at the same time, depending on the conditions, the plant may be trying to conserve energy and protect itself from sunlight by introducing and producing. Oh, man. Do you want me
to tell you?
Let me think 1 second. Is it cyatinoids? What is it?
It's anthocyanins.
Anthocyanins. I mixed different syllables. Anthocyanins. Okay, got it. And that's helps it kind of transition further and keep getting energy for a little longer before the full process takes place and it drops to leaves.
Yep.
And all those things have different colors, and we see them differently because of reasons we've already talked about, which is just energy levels, visible light, a lot of that stuff that's very, very interesting, and basic chemistry.
That's right. You got it.
Ooh, dude, that's interesting. I'm loving it. I'm all about it. I'm ready for these leaves to change.
Well, and I should say I think anthocyanins may be a type of flavonoid, but again, it was hard for me I couldn't find a good resource that said, here is a list of carotenoids, here is a list of flavonoids. So some places seem to conflate them as one, and some separated them out. So it could be that an anthocyanin is a type of flavonoid, but it definitely is a new pigment that gets introduced later on. So I separated it out from the other ones that were already in the leaf.
Okay.
Just as a disclaimer for any of you biologists out there that know more about this than me. So that's it. That's the story. Good job. We're back to a normal episode after a few that were kind of unconventional. Yeah. So that was fun.
Yeah, I did. I was a little rusty on my explanations, but that was a fun one.
Well, do you have something happy from your week? Another fun thing you'd like to share before we wrap it up?
I do, actually. We had one that was really fun and happy, but also a little bit hard. We took a road trip with our kid, which is challenging.
Oh, yeah. Yeah.
Yeah.
Definitely.
We went up to see some of M's family in Indiana, and we did that safely. We'd kind of waited for a while to make sure we could do it safely, and none of them had met our son, and so it was really good to get a chance to do that and see them. and also to be in Indiana where the weather was nice and fall-like, which is perfect for this episode. And I mentioned that.
Yes. Oh, yes. Yes.
I mentioned that at the beginning.
Lots of pictures that Emily sent me of that. So we'll post some of those fall leaves from Indiana. So
that was fun and happy and good. And we made it, and we survived a road trip with a baby and have recovered from the tiring nature of that. So,
well, congratulations on making it.
Thank you. What about you? What's been happy about your week?
Well, some of you may know that the Dallas Stars did go all the way to the Stanley Cup final, which they haven't done since 2000 when I was like 9 years old. So it was pretty wild. It was really fun. I watched some games with my dad and brother. It was a really great time. But one of my former students, current friend, she's a grad student now. She started as an undergrad, and I actually taught her in her organic chemistry lab, and then she decided to go to grad school. So we got to stay friends and actually get to know each other after she was my student. She got me a Dallas Stars jersey with the patch from the Stanley Cup final on it.
Aww.
It was such a nice, thoughtful gift, and it had my name on the back, and there's 5 members of my family growing up, so it had the number 5 on there, and it was really cool and such a nice gift. I mean, it really was so thoughtful, warmed my heart. I mean, I was not expecting it. She said it was sort of a graduation gift, and it was so sweet. It was just a really thoughtful gift, and she even wrapped it, which if she had just given it to me, I would have been amazed.
Right.
So that was a really nice gift, and I was so honored to receive it that I just wanted to share it. And it has the Stanley Cup final patch on it. That's so exciting. So that was a really nice gift.
I think that is really nice. Wow.
So thanks, Ashley, for that sweet gift and for being an awesome student. She was an awesome student back in the day when she was in my lab. So,
and she's still an awesome student right now, right? In grad school?
Yes, but she's not my student.
Right. Okay, got it.
Yeah, she's my peer, not my student anymore. So I'm sure she is still awesome, and that's why she's doing well in grad school. But so thanks to Ashley, and thanks to you, Jam, and all of our listeners for coming and learning about fall leaves.
Anytime, and thanks for teaching us on such a cool topic, such a seasonal, and it'll be fun to watch this topic play out before our eyes as soon as leaves start to change. So Melissa and I have a lot of ideas like this for topics of chemistry in everyday life, but we want to hear from you, the things that you're curious about, the things that you wonder about that are chemistry that you interact with every day or every season or whatever. So reach out to us on Gmail, Twitter, Instagram, and Facebook at Chem for Your Life. That's Chem, FOR, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to A. Collini and In Newell, who reviewed this episode.